Hi everyone. Good evening to all of you. I hope you can hear me, and I have my voice is audible to all of you. Okay, all right, great. It's good to see that we have very few people joined in the webinar. Um, but I think we can have a chat to understand and discuss mostly with every individuals to know about your interest. I think in the meantime, maybe if we give a couple of minutes to people who want to join late, we can have in the meantime we can have a quick chat and understanding about what interests you to be here in the today's webinar. Yeah, I would like to have everyone. Looks like we have very few people as of now. Uh, Anybody would like to, inform or tell about that what is your objective today to discuss in the webinar, or you have any specific expectations and questions that you want to clear by end of this webinar? Anybody would like to unmute and give your inputs? Okay. Anyone? Usman, Samuel, Kishore, Himanshu. Is there a specific interest that you have that you want to take part in this webinar today? You just to get to know about you a bit so that I can discuss and tailor the webinar discussions surrounding to those topics. Anyone here? All right. Okay, so I don't want it to be a monologue just from my side, right? So we just inform you what exactly it is. But I think it's a small group of people as we have gathered today to productively spend our time, and possibly you are interested to explore maybe the career opportunities or what exists for you. If it's all okay, can we start maybe with what is your background of studies and what exactly you do? Are you a student or you a graduate? And if you can, what interests you to be the part of this webinar? Yeah. Let's start with one by one. BULUSU. Yeah. Would you like to go in and say, what's your background and where you're from?
I'm currently a student in RV College of Engineering.
Okay. Which year right now you're in?
Currently in third year, BE
All right.
Mechanical.
Okay. All right. Good to know. Thank you. So I think next we have Ch CH Chavada, Hitendra Bhai.
I am working in TDSG currently.
Ah, okay. Thank you. Uh, I think there you sure you might have sent us a message. I just now interested to know in very low range, low cost EV vehicles. Okay. I think that may not be a topic we would like to discuss about, the skills and, pathways and career opportunities. Mostly we'll focus on that. Kishore, Rahul Varnekar, where are you from? What background you're from? Can you unmute and give your inputs?
Hello, sir.
Hi, Kishore.
I am mechanical third year
Mhm.
from Anna University.
All right. Good to know. Thank you. And Rahul, are you there? Okay. Yeah, go ahead. All right. So I think we have three more people. Samuel, can we have your quick background?
Good evening, sir.
Hey, good evening.
Uh, so, for this event, for this webinar, I had a small question.
Mm-hmm.
So, what are some tools or softwares like MATLAB, Simulink, or CATIA?
Mm-hmm.
Which of these tools or softwares should we prioritize learning?
All right.
And I am a final year automobile student at Christ University.
Sure. Sure. Good. Thanks for the inputs. I'll try to have those pointers focused on that. That is also one of my intention today. So yeah, thank you. And we have two more people, Usman and Yashwant. Yep. Any one of you, can you go ahead, please, quickly?
Hello, sir.
Hello. Hi.
Uh, I am Mason. I'm doing my bachelor's degree in mechanical engineering at Anna University. I'm
Mm-hmm.
currently in pre-final year.
All right. All right. Thank you. Yeah, Usman, over to you. Not sure if you're speaking, we are hearing you. All right. Great. I mean, thanks a lot, everyone, for giving your quick intro and background. Uh, I was also maybe in these similar situations when I was graduating out of my engineering. That is back in 2012. Um, I had a lot of interest to work in hybrid vehicle technology because EV wasn't something that was picked up so greatly at that time, but the hybrids were. Toyota has made their many of the hybrid vehicles, and the most famous one was the Prius. I don't know, something was very deeply interested to me, and I wanted to get into developing hybrid engines. There was no one to tell what you have to study or what capabilities you should have, what skill sets you should have. And this was always been a challenge to realize, hey, if you know these skill sets, maybe you would be working in these areas, right? And at least we don't know whether we will work or get a job, but at least you should have these skill sets to be very relevant to those job roles in the industry, right? And I went through that journey when I was graduating myself, and through the journey of founding Decibels Lab, and that was a main motivation also to start this company. Though we focus on education, we do a lot of other things in terms of setting up labs, in terms of setting up R&D, but still at the core of it, it is always about that how do we help people in realizing what passion they have and what domain they can pick, and how do they become more competent in that domain. So that's the broad context. I can realize a lot of you who are here maybe wanting to work in specific areas, wanting to know what skills you need to have or what domain you have to pick. What does the industry looks like when you actually go out of your college and then pick it up a job. So let's set the context in place that as Vinayak has named this webinar in a specific way, skills, roles, and career and stuff like that. So the first important thing, right? So the EV as such has many things, correct? And it's not a small thing. Maybe just for a few seconds to get us context for this webinar, right? There are a lot many things in EV, correct? Just to set it. until maybe we go back to the screens and stuff like that. So it depends upon what stream of engineering you are. But today there are a lot of multidisciplinary, interesting areas. If you take EV as altogether, it has maybe, as you know, everything remains the same. Maybe your structure of the vehicle, the suspensions, and a lot of other components, door trims, many other components like HVAC systems, comfort systems. All of them do remain the same, right? That means most of them predominantly have electronics today. Maybe if you take suspension systems or if you take vehicle dynamics altogether, right? There is a lot of electronics, maybe like something like drive-by-wire, right? Or steer-by-wire. And a lot of electronics has gone in, not just mechanical engineering as a domain altogether. And today, autonomous vehicles are coming in. There's much more electronics in these areas of vehicle dynamics too, because to control the vehicle. Broadly, those domains remains the same, like BIW engineering. I have many of my friends used to work in a role called BIW engineer. That is majorly to do with a lot of sheet metal components and design of sheet metal components, design of stamping systems to make the sheet metal get into the shape, and then the getting the robotics assembly lines, because you need to get all of these sheet metal components to get assembled through the welding processes, basically the production planning. A lot of these tools are also used in simulations and stuff like that to do this kind of production planning and manufacturing activities in place. Apart from it, there are hundreds and thousands of components, maybe if you like seats and trims, foams, steering systems, braking systems. A lot of these systems remain same pretty much. There are, today you have a very good access to internet, right? If you go and list the top 10 braking companies in India, right? You would get the list of top 10 braking companies. You can go inside them and check like what exactly they do. They may be just making one brake line, right? Or the hydraulic tubes and stuff like that. Or they may be making the pistons, they may be making the manufacturing of the discs, or they may be developing a lot of electronics around it, so like somebody like Bosch. Or many other companies. Like if you take seating systems, right? So there is Lear, there's Magna, there's JCI, and Harita. There are many other companies, right? If you still want to work in the automotive domain, you can work in those areas, which is broadly categorized as the same existing job roles do exist today in terms of these industries. There is design, there is a simulation for FEA, there is a simulation for CFD, there is a simulation for manufacturing, right? Those typical job roles would remain same, as I meant to tell you in setting up the context for the webinar. But what are the new areas, right? So we had engines before. Now engine is replaced by the motor and transmission together, right? And we had ECU for engine, right? So now these ECUs are mostly replaced with motor controllers for the motors, correct? Then we have the fuel tank and fuel dispensing systems and fuel management systems. And now we mostly have a battery, right? So the energy storage systems as a battery, and then we have the software, a hardware layer called battery management systems, right? Which sits on top of the batteries. Then we have charging systems, which is basically receiving AC to AC and converting to DC like an onboard charger. Or possibly we may have off-board charging technology, right? So these are the new entrants, right, in the market. We had engine, so engine cooling system was there. So now we have battery, we have a battery cooling system. We have a motor, we have a motor cooling system. So similarly, we have alignment that we can take broadly from what we had in engines and other systems, but today they have been translated to motor cooling. Like we had engine cooling specialists. Now we have motor cooling specialists. And then the similar way we have the battery cooling, which is much more critical than the engine cooling requirements in place, right? And these are more of the classical job roles, right? Which still exists in the same way because somebody was designing engines, right? They still can work on designing motors. And there were people working on designing thermal management systems for different components. They can still continue to work in battery cooling system, power electronic cooling system, maybe for cooling chargers, cooling the motor controllers, cooling DC-DC converters and stuff like that. So those are like classical opportunities that do exist for any product altogether. It really depends, what role that you want to be in, right? So if you want to be a design engineer, you want to be a simulation engineer, you want to be a manufacturing engineer, or manufacturing simulation engineer. Based on those, interesting areas, you can for sure pick up the skill sets that you want to, build on top of it. But if you these are the, say I said, like classical opportunities which you do have. But coming back to something like the new age job roles, right? Which are typically about battery engineering, correct? Because battery is not something new, right? First lithium ion was commercially put out in 1982, I think, by Sony. 18650 cells came out from Sony for a mass production to many of the laptop batteries and camera batteries and stuff like that. So though it is not fairly new, but batteries for automotive is slightly new into an Indian context. So there are many, many, many things surrounding to the battery technology. All right. Maybe I just show you a quick overview of what it looks like, right, when it is a battery. I try to derive these discussions through some of the the videos that we may have in our lab facility. Right. So if you pick up something like battery engineering, right? Sure. So this is quick example.
Hi. Set.
Let's mute this up. Okay. So if you see, like, this is more like an application engineering, right? So there are companies who manufactures these cells, like that looks to you in green, blue, orange, yellow. This is made by someone, correct? So if you can go to a phase behind this. When I say the phase behind this, that means imagine designing a lithium-ion battery. Okay. When you say designing, there's a lot of things. Maybe it is a lot of manufacturing things, a lot of thermal things, chemical things in place. So there are a lot of people working in creating materials, right? Anode materials, cathode materials, electrolyte, separator, copper, aluminum, which all goes inside the cell. So you can be a chemical engineer working in developing or synthesizing materials, right? Specifically suitable for energy storage applications or applications for the batteries in place. Or you can be a more specialist in manufacturing processes, because once the materials are available, so what else you do? You try to manufacture a cell. There are a lot of people in the manufacturing or prototyping of a cell where they try to combine specific type of manufacturing processes to do a large scale manufacturing, right? There are a lot of differences between manufacturing something, a small cell at a lab scale, and then a cell at a large scale manufacturing sectors. And then there are a lot of areas in terms of the thermal design of the cell or mechanical design of the cell. There is also engineering perspective of core departments of mechanical engineering and other department of engineering in place, which involves in it. So once the cell is manufactured, right? So that means you can imagine what are the opportunities that comes before the cell has been manufactured, right? And then the industry of once the cell has been manufactured. So once you have the cell in place, you want to know whether the cell is suitable for the application, whether it is not suitable for the application. So there's a lot of understanding about testing the cells and characterizing the cells, right? That's what I'm just trying to showcase in this right now, explaining in the video. So we have test engineering teams who basically use this kind of facilities to test the cells, to study their behavior, to study their characteristics, right? And mostly there are engineers working in application engineering. That means not all the cells are suitable for all the application. So that's a kind of a small new areas of job roles. Apart from it, there are also engineering roles for something called digital twinning. That means creating mathematical models for understanding the battery, creating model for developing degradation characteristics of the cells. So there are variety of job roles where the people typically use tools like COMSOL or tools based on Python, or there are tools even based on MATLAB and Simulink for creating digital twins or mathematical models of the cells. So those are some areas where you can also pick up some of the skills for yourself, right? There are people working once these cells have been understood, right? Okay, hey, this is a cell. I can use this cell for this application. I know how the cell will behave over the number of cycles, right? So that comes a perspective of understanding about cells. So you can be a test engineer. Every industry in the country or world will have these facilities. Maybe if you go to Ather, Mahindra, TVS, wherever it is, they will have this kind of a labs and facilities. Or there are companies like Tier 1 companies like Bosch, Continental, Delphi, right? Or any companies who supports and developing battery packs or consulting battery packs. They also will have facilities. So you may be able to learn yourself on that. So there are some other things which we call it as non-destructive testing. Maybe if you're a mechanical engineer, you would realize that, right? So there are different type of analysis. If you take examples like previously, the one I was showcasing you is called as a DC characterization. And here we have characteristics like AC characterization. We test the cell and we study the cell and understand the cell to know its internal characteristics. As I was explaining you, the cell consists of many components, like in that electrolyte is one component and variety of other components are also there. These kind of instruments are today used to know the cell, what is happening inside the cell, why the cell is behaving this way. All such studies can be done with the help of these equipments. These things will help you in realizing, how to understand the cell. Okay. So once you are done with this as a part of learning or building your capabilities, you can go more in depth in developing your knowledge or capabilities in developing BMS, right? Again, it depends upon what background of engineering you're from. So these are some things that we have as a hardware and a software setups in our labs, where we teach the students with the help of these equipments to learn about how to do software development. So now let's say the cell, how the cell behaves, how the battery behaves. Now you can work on writing the software. So when you want to write a software, it is more of an embedded software engineering, right? Where you have today, I would not say, because we have engineers who are mechanical engineers, they write software. Okay. I think the days are gone anymore that I'm a mechanical engineer. I will only design, I will only manufacture things, right? It's up to you. If you're interested, you can also write software, you can design electronics. And we have a team who is doing all of these things, who are mechanical engineers who possibly have designed these PCB boards, right? So to get back to the topic, is that if you take something like a BMS, like a battery management system, you can either work as a hardware engineer to design the battery management system, or you can work as a software engineer to design the software for the battery management system. You can be a test engineer or a validation engineer to work on validating the BMS and doing the end-to-end insurance that these batteries or BMSs doesn't fail in the field. If you want to be a hardware engineer, you can pick up skills on physical electronics hardware, starting from components like everything, resistors, inductors, capacitors, to doing schematics, doing circuit simulations, maybe in LTSpice, PSpice, and variety of toolboxes. Then if you want to make hardware by yourself, you can pick up a lot of Altium. There are tools like KiCad and variety of design tools for designing, physical electronics hardware. right? And then, this manufacturing of electronics and then testing and validation of electronics. If you want to be in a software engineering, you can learn MATLAB and Simulink and Stateflow and a variety of tools. Like the way I'm explaining on the video, you can make your models and you can deploy the software directly into the hardware. Or you can also know microcontroller-based IDEs, right? Example, NXP has its own IDE, the ST has its own IDE, or nowadays, believe me or not, you can develop these softwares with the help of AI and tools like Claude or ChatGPT and things like that. And today, many of our engineers integrated the software development cycle with AI. What used to take 5 days, 6 days, now can be done in 1 day, right? Or 2 days. That is the scale of developing softwares have improved with the help of AI and things like that. So anyway, we'll come back to this topic. Like in similar, you can work on developing the software. There is also close alignment of integrated uh, uh, activities such as testing and validation or verification and validation. Okay, where you can be a test engineer doing mill testing, sill testing, and field testing and hill testing, or you can do more of a physical vehicle level testing or a unit level testing, more on the testing and validation job roles that you can pick for any software side or a hardware side of a BMS. Most of the job roles would remain the same. If you take motor controllers, if you take chargers, the domain may change. Okay, the domain means you're designing BMS, maybe you design charger. There, a lot of power electronics, a lot of other digital control engineering will come into a picture. But the process of developing the job roles for these products would possibly remain the same. Okay, so that's just a touch base on, let's say, the core of batteries or battery management systems, and in each of them, you can pick up certain skill set verticals. And these are the labs that we have at Christ. If you really want to learn something really practically to pick up your skill sets. That's just a quick ideation in the battery if you are interested to pick up something in the areas of battery. Okay, if you are interested to pick up something in the areas of powertrain, okay, and then we have variety of things that you can learn. I would say understanding of motors. Okay, maybe just give you a quick video run through when I'm briefing you out. Right? So we study maybe motors at a very minuscule scale at our academics at times in place. But if you really want to be a powertrain engineer, you really have to understand more and more depth about motors. Because there is a lot of development happening within motors and indigenous of motors. Where there is a core development of magnetics or reluctance activities, where people developing variety of new type of motors, which align to core of electrical engineering. So in alignment to that, obviously there is a mechanical engineering in terms of the design of the motor, thermal management of the motors and things like that, apart from electromagnetics. Then there is a lot of areas for material development. Today, people are trying to develop motors which are independent of magnets, because we don't want to depend upon China for importing magnets. And let's say today, I say we will not supply magnets or materials for magnets, then we cannot manufacture motors. People are trying to find magnetless motors, which are less dependent upon the rare earth materials. There are many companies in Bangalore too, or in India, who are working on this. Let us just go back. Now, if you want to know what is the job role that you want to apply, you can say list of companies who are manufacturing or working on motors in a fairly oriented of a research, right? Go and find them. You have access to internet. access to tools like ChatGPT and stuff like that. So you can find them, right? And then go to their website, go to the section called career, click there, get to know what job roles are that they have for, right? What kind of skill sets are they asking you for, right? And maybe you would have an option in LinkedIn. LinkedIn has LinkedIn search for jobs. Go there and find opportunities for designing motors, opportunities for designing motor controllers, or opportunities for jobs for battery management system, or jobs on battery management systems. So jobs on developing lithium ion cells, right? So if you go and find something like this, you would find 10 companies, just list them, look for 10 job roles, and then in the 10 job roles, you would possibly find the skill sets that you really want for any of these roles. So now I'm just trying to give you a header, right? Like the cells was one area, the BMS was another area, then the motors is another area, the motor controllers is another area, right? Until now, whatever you've been touch basing for our discussions till now. So this is very important to learn in depth about the motors as a concept. And apart from motors, we also have the core of whole thing that would be called as powertrain, right? So you can, if you have facilities, you can, get an access to facilities like this. Like right today, we have these facilities in Christ University in Bangalore. So people or students can, conduct tests, study vehicles, study performance of the motor, performance of the vehicle, right? Performance of transmission, all of these things, because now we just had a motor, then we had a controller. Now these two systems components are integrated with overall vehicle, right? That means there's a transmission, there is the wheel and braking systems, and a lot of other components, maybe the battery integrated together to work as an overall vehicle, right? So here we have majorly job roles like powertrain development engineer. Okay. The powertrain development engineer would involve more towards creating system sizing, system simulations. Maybe is it the right size of the motor? Is it the right size of the battery? How does the vehicle will perform with respect to this, right? Those are broad kind of job roles which you would get. Apart from it, you can get the job roles for test engineering of vehicles. You can get a job role for calibration engineer, which majorly focuses on vehicle performance, drivability and homologation and things like that, right? So where you have to have understanding of vehicle testing, dyno testing, component testing. You also need to know homologations like regulations and stuff like that, right? So that's a broad context of what you can possibly pick up in vehicle testing or powertrain testing, right? So once the vehicle has been released with all the R&D productionizations and stuff like that, you can go more towards the manufacturing engineering. Once that is also done, you can pick up more from the service, right? Service means after the vehicle has been sold. Today, there's a lot of electronics, right? There's a lot of opportunities for engineers to work in performing diagnostics, performing troubleshootings and stuff like that. Apart from it, if you go slightly higher the level, you have a service management team who take care of managing a team of people who are working on diagnostics and services. Or if you go slightly above, there are people working on creating diagnostic tools for electric vehicles, creating an ecosystem for taking care of service and repair and managing and stuff like that. And then there is team for taking care of the warranty of a product. There are teams taking care of if the things are getting failed in the field, they would take the parts back to their R&D center. They open the component, they study why did the component fail. More like a failure analysis of components and things like that. Or there are teams for benchmarking. Okay, that means Ather has released a new vehicle. Okay, they buy the vehicle, maybe like 5 of them, 10 of them. They rip them all apart, and then they study all the things so that they can reverse engineer. They can adopt best practices what Ather has done, what Ola has done, what TVS has done, things like that. More of it, that's the context of variety of job roles or skill mappings that may come. So maybe at the last line of it is that the skill sets are very relevant to a job role. It depends upon what exactly the job role that you want to apply for, and you can be prepared for those kind of job roles. So my intention is to tell you that first identify a job role than a skill set, right? Because skill sets are many, but the job roles are few. So according to the job role which interests you or which is available in the industry, you can list down 10 jobs available for this kind of a job role, right? In 10 different companies. And then summarize them, list down what exactly you can learn. In them, maybe you can only find X and Y and Z available for you. Okay. Example, if you want to learn HIL testing, not easily available. I don't know any academy in our country teaches very depth of hill testing. Okay. Because the hill itself is very expensive to procure, maybe in lakhs and crores. So you may not have. So, but something like software development through MATLAB. You have access to MATLAB. You have a lot of courses available across a variety of platforms. So you can pick them, right? And then get yourself acquainted with that kind of a tools and platforms in place. And then hardware deployment. Again, the hardware is not easily available for many of the learners and students. If you can get an access to the hardware, like how we have facilities in Christ in your universities, you can do it, right? So that's the component of it. And then learn through many projects and then graduate. I think then you will be mostly equipped with what you want to get into. I think that's broadly in a context, right? What I want to set across that, hey, you can create this workflow. With this workflow, I think you can identify the skill needs, the job role needs, because you're going to list 10 different job roles, you're going to list 10 different companies. I think in that way, you would know, okay, hey, these are the things that I may be able to pick it for myself over the number of days. I think if I set the context for you and the workflow for you on how do you identify the right things for you, I will open up the session for QA. I think you can ask more relevant questions with our discussions that we had till now. All right, so let's go for questions. Anybody have any questions that we can discuss?
Yes, sir. I have one.
Sure. Go ahead.
So, do certifications significantly improve job chances, or are hands-on projects more valuable?
If you ask me, certification may not have a lot of value, right? Maybe 30%, 20%, they can contribute, okay, depending upon the credibility and depending upon the connect these companies may have with industries, right? It can possibly, right? But 70% is to do with the skills, or I would say the experience that you build over doing some projects, doing practice with the hardware, having being relevant to ecosystem, what industry expects, right? I would say that is more important than a certificate, okay? Because IT industry has many of these things. Microsoft certified AI developer, Cisco certified network developer, PMP certified somebody, right? But I think the core industry doesn't have something of that sort, as I come across these any number of days. Okay. I would believe more strongly in skills, more strongly in the toolboxes that we need to know very specifically relevant to industry. Because if you go and hit these 10 job roles, you would get to know, let's say, Mercedes is only using X toolbox, maybe from DSpace, maybe from Vector, right? They want somebody to know that exactly, all right, than being just certified in X and Y and Z, right? So that's why I say relevant toolboxes or relevant skill sets are the more important things today for automotive industry, because we've been very much constrained around using specific things, not similar to an IT industry.
Yeah. Thank you, sir.
Yep. Thank you. Right. Anybody else have questions from your side?
Hello, sir.
Hi, Kishore.
Sir, let's assume that you are doing third year mechanical. What will you do for your job and why?
All right. First thing first, right? You have to know what you like at the first perspective, okay? Or at least what you can become in the guidance of someone, correct? Then pick up that domain. Let's say you want to work in EV. It's very big, right? It's, as I said, so many things are in EV. So you have to first narrow down what is that relevant domain. Do you want to work in batteries, right? Let's say broadly at that level. You want to work in motors. You want to work in power electronics, right? You can define that niche for yourself. It's good that you're in third year, right? Start doing relevant, maybe presentations to start with. Attend training programs, take up courses available all across, because it's about knowledge gathering, right? Because let's say if it's a battery, that means it consists of cell, BMS, pack, manufacturing, thermal systems, and a lot of these things, right? So you can build, again, depending upon your background of engineering, or if you want to be a multidisciplinary guy, you decide, and then you start working practically on that, right? For an example, I want to work in batteries, right? So what do I do today? I learn theoretical skills that is available on internet, available on courses, right? And then I want to get a practical learning. Either you can do projects as a part of your academics, where you get some practical learning experience. Let's say I want to design a BMS, a simple single cell BMS you can design, right? Or you want to do some sort of a system modeling in MATLAB and Simulink, right? Even if you cannot learn with hardware. Or else you can come to the lab like ours at Christ or Decibels Lab collaboration, where you can learn practically about to work with batteries and stuff like that. And then maybe start working on identifying, building exposure, learning with practicals, do some projects, and then come out with more of a total project-based learning, right? I would say that would be a right direction. In this time of it, find where do you want to find a job, because it's very important. I'm not sure what is your background altogether, but the thing is that you need to know where the jobs are, right? Which are the companies, let's say like there are 25 companies I want to apply for internship. And I have these 10 skills that I know today, right? Start getting to internships maybe in your breaks of your semesters, and then start getting to larger internships for like 5 months, 6 months, 4 months, if your university allows you to do that. Almost if you've done that greatly, I think you will be there at a good job, is my strong perception.
Thank you, sir. That's very clear.
Yep. Anybody have any questions? All right. So just to give a broader context, we discussed broadly about these topics in place. So what I want to also tell is that even including I myself when I was graduating, when we studied engineering, I'm a graduate in mechanical engineering, right? So we did not have a very domain specific, maybe or application specific master degree at that time. Okay. It was very broadly called as thermal engineering. It is called as machine design and things like that, right? So, but when you come to the industry is focused on very specific area. Let's say if it's a machine design, is it like you're designing a BIW? Are you designing plastics? Are you designing casting systems? Or else are you designing maybe mechanisms? Are you designing whatnot, right? Things were not very, very, very specific. That was broadly, portrayed as a very wide postgraduate degrees. So if you have that kind of a interest to pick up yourself into the core domain of engineering, right? I would suggest maybe some of you to figure out if you want to learn your postgraduate studies, okay? And if you are somebody of that sort who seek that, okay, hey, I want to work in this area, that is where I find my interest. Okay, if you can do it through your engineering, it's fantastically great. But if it is not possible, somewhere along the journey of engineering, you could not really find that opportunity for yourself to learn and then opportunity for yourself to land in the job, I would suggest you can pick up postgraduate studies. That would be like an MTech or a specialization courses, right? Because somewhere you have to find that pathway for yourself. So seeing this need in the market, at Decibels, we have launched this MTech program. And, before we launching this MTech program, because we are the partners, Decibels is a partners with Christ University in launching the program, it was very important for us, like, do we have the lab for the students? Do we have projects like in industry to work with students as interns when they're learning, right? So in that way, we have launched this program from last year, that is 2025. We did our first batch, and we have a very limited seats of 12 people in this course. And this course is highly focused to relevance of electric vehicle technology. If you want to, all the images and videos I showcase to you are actually the facilities that is based out of Christ University in Bangalore, and that is where our office is also there. And if you are interested to pursue your career in a very specific area, but you could not pick up this line of interest in your undergraduate degree, if you're able to spare another 1 year, I would not say 2 year, because in the 1 year itself, your course mostly finishes. And then in the second year, you can go for internships. And that would be mostly the paid internships, right? And so that you don't have to waste like 2 years, but mostly 1 year. And then the second year is mostly focused on job or internship opportunities at industries and things like that, right? So you can choose. Maybe we are the one organization. I would be proudly to say have such facilities and aligned industry collaboration, industry projects which go in and out here in the lab, right? which gives you a learning opportunity and access to learn relevant things. And though if you're interested and if you're not able to find, so we have this programs running. I think we are running an opening of the batch for this year. And if you're interested, you can also take part in something like this, where you could gain your relevant skills. Okay? If not, we if you think that it's too expensive to spare 2 years, not about the fee, right? But the time. And we do have some of other programs which we call it as like master courses, which are like shorter for like 9 months and 6 months duration, and which makes somebody to build a core competency in one specific area, like developing BMS software, developing powertrains, and developing battery materials and digital twins and stuff like that. So maybe we are an option if you are interested to become specialized in one specific area and look out for jobs from there on. Yeah. That's just a broad context setting. We are just one among the pathway. If you are interested to, figure out about your career along with a postgraduate degree in electric vehicle technology. Cool. So I think that's pretty much on the context side, what I wanted to address. If you have any questions, we would be happy to answer those questions or address them. Anybody have any questions? Okay, so I think if nobody have any questions, that's good. I think we can conclude the webinar. I believe it has given, not I would say everything to plan your career, but a broad context, right? That's how it all starts with. To know, hey, somebody told me that these all things exist. Let me figure out what are these things are. All right. I think that's what I feel it has set for you today on the context. And you can explore now on top of this into more further things. Or in the future, if we arrange programs or short-term courses, you can be a part of the visit to our facility where you can practically see these things and also learn these things, if you're finding interest in these areas. So I think, yeah, that's pretty much from my side. If you have no questions, I would hand it over to Vinayak. Vinayak, you have anything to add in?
No. I've shared them the links of all the courses you have shared in the session. I think your voice, you're on mute actually.
All right. So, all right, everybody. I think it's great to see you on Saturday, and thanks a lot for joining in, everyone. I hope it was productive, informative 45 minutes for all of us. And thanks again, and have a great weekend, all of you.
Thank you, Suresh, for the session, and thank you, everyone.
Thank you.
Thank you, everyone.